Hovergames. Well, what can I say? It's been an adventure. I learnt so much, and in the end, surprisingly, I discovered that building a flying robot that thinks for itself is actually really difficult. Who would have thought? Initially, my idea was to build the robot, then just copy some code to make the drone spot objects from the air. How hard could that be? Well, this is a story of my journey. As we were going into lockdowns in Melbourne, I saw the episode of Flight Test where Ian built a VTOL drone and programmed it to fly autonomously. And as I had just been getting into drones and wanted to learn programming, I knew this was the perfect project for me for this year. I immediately ordered all the drone parts from NXP. They arrived within a week and I was so super excited to get underway. I should point out that I'd never actually flown a drone before this year, so I didn't actually have any concept of how difficult it is to build one at this scale and program it to fly autonomously. Crash after crash after crash occurred. Each time it was something different, to the point where the drone was so broken I had to 3D print all new parts for it and rebuild it. That's one major thing I discovered with drones. If anything slightly goes wrong, it just falls out of the sky, the same as a rocket. So we were in strict lockdown in Melbourne. All businesses were closed to the public. We were only allowed 5 kilometres from our own house for 1 hour each day. Local parks were full of people exercising their dogs, so finding places to do flight tests became increasingly difficult. I ended up discovering a secret path to the back end of a local golf course, which was perfect, so sneaking in there for test flights became routine. Eventually I got the drone to fly without crashing and fly fully autonomous missions without it falling out of the sky. So that was step 1, which took several months. Next came the programming bit. The nav queue. I had never operated a computer without a screen before, so I had to learn to operate the nav queue from the Linux terminal via SSH from another computer. This was an added layer of difficulty at first, but after a few weeks I got the hang of it. After weeks of trying from dawn till dusk, following endless amounts of instructions that I didn't understand, and tapping in codes that I had no idea what they meant, I managed to get the nav queue talking to the Pixhawk, sending data for telemetry over Wi-Fi to the ground control station, and managed to get the video working to the ground station too. My original idea was to broadcast the video to a website so people could join in the search for lost friends in a search and rescue operation, but I was never able to get the video to be high quality enough to make it worthwhile. It was always scratchy and low resolution. I was hoping 5G would come in time to change that, but unfortunately 5G dongles start at $500 and the coverage is currently minimal. My programming experience at the time was programming rockets to fly autonomously in Kerbal Space Program using a language called KOS, which is a made-up language for KSP. So I began learning OpenCV in Python and quickly realized that using artificial intelligence from a robot searching with a camera in the air is so much more powerful than anything the human eye could spot in a moving image. I created a Python program that could pick out colors and used some of that on the drone footage I had to detect the color of my t-shirt, and it worked amazingly well. I experimented with all the different OpenCV algorithms, detecting faces, torsos, legs, all seemed to work exceptionally well. But the big problem was the processing power required and the latency. On my 12-core beastie computer with all 12 cores going flat out, it was barely able to produce a frame every few seconds. So if the drone is travelling at 5 meters per second, there will only be one frame every 15 to 20 meters covered. Also, the question of once the AI detects something, what do you do with that information? I had ideas of the AI being on the drone and piping the video back so humans could watch it and see what the AI detects. I was never able to transmit the video after processing it on board in Python. I went deep into learning GStreamer. For those of you who don't know what GStreamer is it is by far the most powerful video software ever made, created by pure voodoo magicians, and almost unusable to those of us born in the human realm. I watched hours and hours and hours of tutorials, experimented with it endlessly. I now know a huge amount about it, but I still feel like it does so much more. I had the idea of sending GPS points every time it detects something, so I went deep into learning drone kit for Python. Bought the 12-hour course, watched it, did all the exercises, but still, it seemed like voodoo magic. So I could get all the elements working individually, just not all together all at the same time. I realized I didn't have enough fundamental knowledge of what I was doing, and I had jumped over learning the basics and going straight into building a flying robot. So I stepped back from the drone and watched hours and hours of computer science lectures from universities for days and weeks on end, and signed up to a bunch of Python and C++ courses and just began practicing the fundamentals every day. The embedded Linux engineering courses helped my understanding immensely. I figured it would help my understanding to build the same thing but with different tech, so I built an autonomous rover using Raspberry Pi, an Arduino and a Pixhawk 2.4.8, and discovered that building a rover had its own huge set of complications, and instead of taking a few days, it took about 2 months and 3 rebuilds before it was all operating well. But it did become a hit with kids at picnics and music festivals. I also built a computer from scratch, selected the microchips, soldered them onto a prototyping board, installed a bootloader, and then wrote the software to control the rover. After reading a lot of blogs, I had come to the conclusion that there must be RF interference happening between all the components on the board. So yesterday I did a thorough test with my SDR kit and went through looking for RF interference. As RF is a fairly voodoo grey area, there are many opinions. After a whole day of testing, I failed to find any major interferences, so I guess the next step is going to be how to upgrade the antennas to the optimum. So all in all, I have learnt a phenomenal amount from doing this all year. I'm now at the stage of understanding how to build your own firmware, how to write programs to be multi-threaded through the processor. I realise for something to work with speed on a drone, it needs to be written in C or C++, so the challenge will be how to incorporate the elements of Python that have pre-made libraries for detection, whilst talking to the hardware in C and utilising the multi-threads of the processor to the maximum. So in summing up, I feel like I've found all of the problems associated with the question and all the answers to the questions, so combining them into a functioning robot is next. So unexpectedly, as it turns out, that building a flying robot that thinks for itself is actually really difficult. So my next challenge, which could possibly be ready for next year's Hovergames, will be to build the firmware from the ground up for the NavQ, write vision detection software that works intrinsically with NavQ's hardware for real-time AI vision detection, and hopefully once proper antennas are in place, it can beam high-quality video back. That wraps up Hovergames 2 so far. We'll have to see what happens next year. Thanks for watching.